Let's open our eyes to the world that's around us. Science has the answers to the questions that have found us.
Melia Science.
Hi, Mr. How's it rolling? How much does the Earth weigh?
All right, how much does the Earth weigh? How much do you think the Earth weighs? A lot. All right, well, we got this scale. Let's see how much the Earth weighs. Let's put it down on the Earth. Watch out, Troy. All right, how much does the Earth weigh? 0 pounds. Nope, that's not going to work. Hey, really, honestly, the Earth weighs about 13 octillion pounds. Can you say that? 13 octillion. There you go. I said it right.
13 octillion pounds.
About 13 octillion pounds. And let's take a look at just how big that actually is.
Alrighty, we said that the Earth weighs about 13 octillion pounds. But how big is 13 octillion pounds? Well, let's compare it to something else that we consider pretty heavy. An African elephant, an adult African elephant, weighs about 13,000 pounds. 1 3 and 3 zeros. But that's not even close to the Earth's weight. Let's say we have 100 African elephants. I know this isn't 100, but it's hard to find a picture of 100. But 100 African elephants would weigh about 1,300,000 pounds. Still not even close. Now, 1 million elephants. Would that weigh as much as the Earth? No. That would weigh about 13 trillion pounds. Whoa, what about 1 trillion elephants? The Earth weighs 1 trillion elephants. 1 trillion elephants, there are not even this many on the Earth, would weigh 13 quintillion pounds. And that is still not as much as the Earth. As a matter of fact, the Earth weighs 1 billion times more than 1 trillion elephants. So that's a lot. That's a lot. All right, we hope that answers your question. Let's look at the next one.
Hi, Mr. How's it rolling? Why do my batteries in my toys die?
Dearly beloved, we are gathered here today to mourn the death of this battery.
Poor flashlight.
Your poor flashlight won't run anymore. Okay, so batteries don't really die, but they do lose their charge. And a lot of people think, oh, well, inside this battery, there's a bunch of electricity stored, and then it releases it and it runs out. Well, that's not quite what happens. Let's take a closer look at what's inside a battery and what happens when it loses its charge.
All right, so how does that battery work? Inside the metal case of a battery, there are 3 main chemicals: zinc, manganese dioxide, and potassium hydroxide. It might sound complicated, but the way the battery works to make electricity is actually pretty simple. A chemical reaction takes place. It's when you mix 2 chemicals and something happens. It's just a chemical reaction, which moves tiny negatively charged particles called electrons around to create an electric current. And when that battery is connected to a circuit, like a light bulb, or for example, the zinc inside reacts with the manganese dioxide and loses their electrons because they're traveling around the wire, and then they hit the light bulb, they get to a semiconductor, which they slow down, they run into each other, and they create light and heat. And then, when most of the zinc has reacted with the manganese dioxide, we say that the battery is dead or flat, which means that it can't make any more electricity because the chemical reaction that takes place in the battery can't easily be reversed, and you can't recharge it. But remember, most batteries can be recycled, so make sure you get rid of them very carefully.
Hey, Mr. How's it rolling? How do flies and spiders walk on the ceiling?
So, how do spiders and flies climb walls and ceilings? That's a great question. Let's go ask an expert, all right? Follow me, camera lady of science. Hey, Spider-Man, how do spiders and flies climb walls or stick to walls and ceilings?
Well, they do it both very differently. You gotta look at their feet to find that out.
Okay, Spider-Man, let's go take a look at the feet of spiders and flies and see how they climb the ceilings and the walls.
Okay, here's an average fly sticking to the wall. Let's see if we can zoom in on his feet about 120 times magnified and see what they look like. Okay, there we go. 120 times magnified fly foot. You see, the fly foot gets its grip with the sticky hairs and with claws shaped like a set of bullhorns. You can see that all those little hairs are secreting a little sticky substance, and it gives it more surface area so he can stick to the wall. And it enables the fly to walk upside down. Now, okay, so his foot is stuck there with the sticky substance. How does he get loose? Well, pretty easy. They have four different ways that they can get their foot loose. You know, a fly could just push his foot away from his body, causing the foot pads to fold up and lift free. He can twist his foot to get free, peel off the back of his foot pads by using those claws, or he can simply just yank backwards and scrape the claws across the top of its foot pads, and he is free to fly around. So, little sticky hairs on the fly's foot. Now here's a spider sticking to the wall. Let's zoom in and take a look at his foot. Now again, we see that the spider's feet is covered in tiny hairs. The little hairs on their feet are covered in even smaller hairs called sexuals. A spider has more than 500,000 of these sexuals, all of which are triangular, end in a triangular tip. And these are flexible hairs, not like pickaxes, and they don't dig into things. Now, they help them with a phenomenon known as the van der Waals force. It's produced by the spider's sexuals and gives them a sort of magnetic hold with the surface. Essentially, this means that oppositely charged molecules within microscopically close proximity, which means positive and negatively charged, they have different charges, electric charges on them. Everything has these charges in them. In a really close space, can create an attraction like a magnet. So think of the tips of the spider's sexuals as tiny magnets that allow them to stick to any surface. And since they have more than 600,000 of them all over their body, they can grip to almost anything.
Well, great questions, Melia gang. Keep on coming.
Let's open our eyes to the world that's around us. Science has the answers to the questions that have found us.
Melia Science.